In the last few lectures, we have seen what are static and what are dynamic systems, and the next classification is causal and non-causal systems. We are discussing causal and non-causal systems together because they are closely related. We can easily differentiate between causal and non-causal systems, and in this lecture we will see the definition of causal and non-causal systems along with few examples to have better understanding of the definition. And once we are done with the basic concept of causal and non-causal systems, we will solve few more examples which will make this topic crystal clear. In order to find out if the given system is causal or non-causal, we will again check the relationship between output and inputs like we did in case of static and dynamic systems. And to do this, we should know what are present, past and future inputs. And as we have already solved examples based on it, I will not explain it again. We will directly move on to the definition of causal system. Causal system is a system in which the output of the system is independent of future values of input. So this is the definition of causal system. Now let's try to understand this by the help of few examples. In the first example, the output yt is equal to xt, and you can see output yt is dependent on the present input. So the system is producing a relationship in which the output is only dependent on the present input. That's why it is causal in nature, because causal systems are those in which the output of system should not depend on or independent of future values of input. And here the output of the system is independent of future values because it is only dependent on the present values. So we can define the causal systems in another way. We can say causal systems are those systems in which the output of the system is only dependent on the present input, or the output of the system is only dependent on the past input, or the combination of both. It can either depend on present input, past input, or the combination of both. The future values of input should not be there. Let's see one more example to understand this. In this, yt is equal to xt plus xt minus 1. So this one here is the present value of input. This one here is the past value of input. So output yt is only dependent on the present and past values of input. Therefore, this time also the system is causal in nature. So I hope you now understand what are causal systems, but there is one more point regarding the causal system which we must understand before moving to the non-causal systems. All real life systems, or we can say all practical or physically realizable systems, are causal systems. Let's take one example to understand this point. In this example, let's take two different systems. The first system is system 1. This is the representation. And the second system is different from first system. I will explain what is the difference. And I will call this system system 2. And in both the systems, the same input is given. Let's say the input is xt, and it is given to system number 1 and it is given to system number 2. The output of the first system is, let's say, y1t, and the output of the second system is, let's say, y2t. Now the difference between first system and the second system is the delay. In the first system, the delay is equal to 0, and in the second system, let's say, the delay is equal to 1 second. The delay is equal to 1 second. This means in the first system, when input xt is given, when input xt is applied to system 1, the output y1t is produced instantly. On the other hand, in the second system, as delay is equal to 1 second, when you apply input xt, the output y2t will be produced after 1 second. So this is the main difference between system 1 and system 2. We are not focusing on the exact relationship between the input and output. We are focusing on how output is dependent on the input. So what will happen when you provide signal xt to system 1 and system 2 at t equal to 0? In this scenario, y1t will be y10 because t is equal to 0, and y10 will be present value of output, and it will depend on x0, why x0, because delay is equal to 0, and as soon as you provide the input when t is equal to 0, the output will be based on the same input you are providing at t equal to 0, and the input is x0. So x0 is the present value of input, and you can see the present output is dependent on the present value of input. So we can say that the output is only dependent on the present values of input, and this will only possible when delay is equal to 0. So when delay is 0, the output will depend on the present values of input. So what is happening in system number 1 is very clear. Now let's move to system number 2. Here delay is equal to 1 second, and you are providing signal x0 when t is equal to 0. The input signal is x0. So output y to t will be y to 0, and it will depend on x minus 1 because there is delay of 1 second. And when t is equal to 0, actually the system is providing us the output which is based on this signal when t is equal to minus 1. 1 second prior to 0 is t equal to minus 1. So we will have the output based on x of minus 1 when t is equal to 0. So the present value of output is dependent on the past values of input. So this is the difference between system 1 and system 2, and all real life systems or practically realizable systems are having either this nature or this nature, and in both the cases the output is not dependent on the future values of input. So we can say that causal systems are practical or physically realizable systems. Now we will discuss what are non-causal systems. In non-causal systems, the output of system is dependent on future values of input at any instant of time. So if there is at least one instant of time at which the output of the system is dependent on the future value of input, the system will be non-causal. It may depend on past or present values, but it should also depend on the future value at any one instant of time. This will be more clear when we will solve one or two examples based on it. In the first example, signal yt is equal to xt plus 2. This is future value of input. So the output is only dependent on the future value of input. Therefore, the system is non-causal. Let's take the second example. In this example, yt is equal to xt plus xt minus 1 plus xt plus 1. This input here is the present value of input. This input here is the past value of input, and this one here is the future value of input. So the output yt is dependent on the present, past as well as future value of input. Therefore, the system is non-causal in nature. So this is all for non-causal system. There is one more system known as anti-causal system. There is one more system known as anti-causal system. So what are anti-causal systems? In case of anti-causal systems, the property of system is entirely opposite of the property of causal system. In causal system, the output of system should be independent of the future values. Now what will be the exact anti or opposite of this statement? The output of the system should depend only on the future values of input. So the systems in which the output of the system is only dependent on the future values, they are known as anti-causal systems. For example, if you see the first example, here yt is equal to xt plus 2. So the output of the system is only dependent on the future values of input. There is no past or present values of input. So this system is non-causal plus it is anti-causal. So anti-causal systems are always non-causal, but the reverse of this statement is not true. For example, here the system is non-causal, but it is not anti-causal. And whenever you have anti-causal system, it is always non-causal. So this is all for this lecture. In the coming presentations, we will solve few more examples based on causal and non-causal systems.